Hey, in this video I'm going to show you how to make a dial that exactly matches a potentiometer or a knob without using a graphics program. We're going to use code instead. So the reason you'd want to do this is in any graphics program I can think of, in order to make all these spaced lines, you start with creating one line and then copy and paste and then rotate and repeat to create all your lines. You can accurately space them. However, if you don't exactly know the angle of the potentiometer and you get it wrong like I did the first few times, it takes a lot of work to re-edit that, except when you do it in code. If you want to change the range, you can easily tweak it ever so slightly and then just print out on a piece of paper and get it to match. And you can also very quickly change other things too, like your label interval of where and how many labels to put. The size of the labels I can change all at once. And so it updates live and makes the design of labels for gauges and dials a lot faster than a graphics program. Let's look at the code. The first section, these are my variables or parameters that describe my dial. Basically the settings. I tell it how big each of the different reference diameters should be, such as where the labels should sit. I can move my labels in or out by adjusting that number. And things like foreground color, I could invert it. Alright, so there's the settings. Then I have computed settings, which is where I take the millimeter input numbers and convert them to pixels using a specified DPI. Then we'll calculate the size of the canvas based on how big the gauge actually is. Then they have the update function, which is the only function really, it's the most important function, and that will draw the scene of the canvas. We'll clear rect, which just empties the canvas. And then the first thing we draw is, you can't see it right now, but it's the circle that goes around the outside, and then fill that in with the background color. And then I draw the dashes, and this took a little bit of thought because I wanted to have different lengths of dashes so that your eyes can easily see where the 10s are and where the 5s are. So I started by, well actually I have a for loop that runs the dash making code several times, once for each different style of dash that you have. And it will actually draw the smaller dashes first, and then when it goes to draw a longer dash, it will erase the short dash underneath and then draw the longer dash over top of it. And it uses a little bit of trigonometry, sine and cosine, in order to transform the angle into XY positions. Okay, then the rest of it is just, oh, I guess we also have the text for what I call the labels. These are the numbers that are spaced out at important positions on the dial. And that uses similar math as the dashes, but it's actually easier. And I also made a hole in the center that will be a cutout. And this would just be, that's actually a little bit bigger than what I would use for this knob. but that'd be the diameter of this threaded stud. And the other thing you want to make sure is that you incorporate the diameter of the knob so that the knob doesn't cover the line. So if your knob is 30 millimeters, then the dashes should start at 30 millimeters so you don't lose useful information. Well, that is a little bit of a walkthrough. In order to get through everything, it would take too much time, but also